All right, so I am going to go through and say hey to everybody. Let's see. Hey, Alana, Aiden, Ainsley, Aisha 2, Alberto, AJ, Aryan, Ben, Brendan, Courtney, Ethan, Imani, Bella, Jackson, Jasmine, Jordan, Karina, Katie, Maddie, Mika, Mariah, Nicholas, Sadu, and Zaria. All right, good to see everybody this morning. I am going to go over a couple of announcements. Let me share my screen. Let's just share the entire. No, I'll do this first. Okay, again, turn your video off when you get on, please. All right, so I'm sharing my screen with you all. And I guess I need to make this live. I did publish this. All right, so I'm going to go over the work for the week. So you go on my website. As you see, it's coming up here. Weekly lessons, just like last week. And you'll see this week right here. So 4-6 through 4-8, because we have spring break coming up. And so when you go to this week, you will see, this week? This is the wrong week. Hold on. Well, it says the right week. Something's not right. This is what it should be. Did I publish this yet? All right, whatever. It's not published. So by the time I publish it, it'll be there. So let's just do this. This should be Math 1. Okay. I am having technical difficulties because clearly, oh, I put it on the wrong day. Okay. So yeah, I guess I have to update. So I guess it is here. I just put it on the wrong day. That'll be updated. So it might be true, Imani, that you went on and you didn't see today's work because I made a mistake and put it on the wrong day. All right, so here we are. So intro, the video lesson, and that's what we're doing now. So after this lesson, I will upload the video into the difference of squares. That's what we'll be going over today. Then tomorrow, well, today you have a flute with 10 problems from the video. Be really simple. Tuesday, difference of squares part 2. We will have class tomorrow. That's the highly encouraged class, but y'all are here for the optional class. So I'm pretty sure you'll show up tomorrow. I believe at 1:25. No, 1 o'clock. I gotta check the times again. I don't know. I'll put it out in the announcements. All right, that's Tuesday. And then Wednesday, Blast from the Past. You have warm up 1 and 2 in Canvas, and you'll just upload your work to Flute. So a pretty simple week. And then after that, we're spring breaking. Some of you still have not uploaded your work from the quizzes, and you won't get credit for the quizzes until you upload your work into Flute from the quizzes. I believe everybody is on Flute except for one person. I have been updating what things have been completed into PowerSchool. There's still speculation about the grades and everything right now, but we'll deal with that at a later date. Good morning, Liam, and good morning, I think, who just came in? Donovan came in too. All right, so good morning, Liam. Let's get to today's work. So today's work is difference of squares. So let me share. I'll just share my entire screen because I'm not tired of going back and forth. All right, difference of squares. So if you're watching the video, this is the lesson, difference of squares. And so difference of squares is a review of a special product formula. So we did special products where we had a plus b times a minus b, and that gave us a squared plus a squared minus b squared. That was special products, a blast from the past. But today we're dealing with difference of squares, but I'm gonna tell you where they come from. So difference of squares come from the special products. So remember, when we had special products that had the product of a sum and a difference, it produced a special binomial. This is getting on my nerves because this thing is not centered and it's centered on my other document. Like move over. Okay, so I'll say that again. Sorry. When we had the product of a sum and a difference, it produced a special product. So when we multiply this times this, it produced this. So I'm going to do this problem so you can see this. So when I distribute here and here, I've got a squared. When I distribute here and here, I got minus AB. When I distribute this and this, I got plus AB. And when I distribute this and this, I got minus B squared. Okay, that's through 4, right? First, outer, inner, last. What happened is that the outer and the inner term, our OI, canceled out, or they produced 0, and we ended up with A squared minus B squared. Okay, so let's review that. Let's review that again. So if I FOIL this, if I see the product means the multiplication of a sum and a difference, should be the same sum and difference. So x minus 4, that's the difference of x minus 4, and x plus 4, the product of the sum and the difference is going to give us this special product. So I take my A term and I square it. I just do all the math. And then minus my B term, and I square that. So that's going to give me x squared minus 16. Same thing here. If I see the product of a sum and a difference, the product of a sum and a difference is going to give us this special binomial of a squared minus b squared, and you end up with x squared minus y squared. Again, the product of a sum and difference, we're going to end up with a squared minus b squared. And that gives us 4p to the fourth minus 25r squared. Okay, make sure I'm not getting any reminds. All right, so I want you to tell me in the chat, what is the special product of m squared minus 5 times m squared plus 5? Okay, good. For those of you that are still coming in, just keep typing, because people that's watching the video don't want to wait this long. All right, so that's going to give me m to the fourth minus 25. M to the fourth minus 25. So what I'm saying is that today we will be given this term here, and we have to produce the factors. Again, we will be giving this term here, and we have to produce the factors. We're going to be given this term here, and we have to produce these factors. We're going to be given this term, or this binomial, I should say, and we're going to have to produce those factors, understanding special products. So we know where this comes from. And now we call this the what? Come on, next screen. The difference of squares. That's what we call this, the difference of squares. So when we have the difference of squares, we are saying I have the difference means subtraction, of two monomials being squared. When I have the difference of two monomials being squared, the factors are the sum, the product of the sum and the difference. That's what we're saying, everybody. If I have the difference of two monomials squared, your answer, your factors are going to be the product of the sum and the difference. Now notice it does not matter which order that you write them. Usually I say sum and difference. So I usually put the plus sign and the subtraction sign, plus sign first, or the addition sign, plus sign. We used to always say something, I remember in class, they used to always be like, I don't know, I used to say you're using baby words or something. Plus, or it was some word, I can't remember. Anyway, all right, so it's gonna be the product of the sum and the difference. All right, so in order to use this rule, both A and B are squared, shouldn't say numbers, should really say terms, because they're not always numbers. Square terms, you cannot use this if there is an addition sign between A and B. That's why it's called the difference of squares. Y'all. If this is the difference of squares, the difference of two monomials or two terms squared, then it's not the sum of squares, it's the difference of squares. So you must see a subtraction sign in between the two numbers, okay? So if a polynomial cannot be factored, we know it is primed, or some people call it can't be factored. So let's look at this. Let's get into the work. So x squared minus 1. So I see the difference of two monomials, but is it the difference of two monomials squared? So if I wanted to get x squared, class, what would I have to square? Good. If I wanted to get 1, what would I have to square? All right. So now I see everybody the difference of x squared, x being squared, which would be my A, and 1 being squared, which would be my B, which would be x squared right here, and then 1 squared. So that turns out to be the product of the sum and the difference. So this turns out to be x plus 1 times x minus 1. What was being squared to get x squared? X. That's my A. Same thing as my A right here, everybody. This A gives me this first term squared. What was being squared to give me 1? 1. That's my B. Okay, so if you have a question about that before I move on, because that's the foundation, because they get a little, a little harder, please just let me know privately. One student asked, do either of the expressions at the top work, or is it specific? This is the foundations of all difference of squares. So your A represents any number squared, any monomial or term squared. B represents any monomial or term squared. So this is the foundation of everything that's about to come. Any more questions? You can ask me privately if you don't want to put it in the entire chat. All right, so the question I'm seeing, they need more examples. So that's exactly what we're about to do. All right, so 25g squared minus 9k squared. Actually, I'm gonna go to this one first because this is a little easier. I meant to put this one before this one. All right, so we have h squared minus a squared. So when I see the difference of two monomials, I ask myself, is this the difference of squares? So today, that is the question you're asking yourself. If you see the difference between two monomials, okay, you're asking yourself, is this the difference of squares? So in order to get h squared, I had to square h. In order to get a squared, I had to square a. So yes, this is the difference of squares. It's the difference of h plus a times h minus a. Okay? Again, if I have the difference of squares here, right here, if I still have the difference of squares, I am saying that these are the factors. Nick says, I still don't understand how. Okay, so I'm getting a lot of questions, and that's why I told y'all it's good that y'all come on today. All right, so again, everyone, let's go to the back. Let's go back here because we're not making connections, and let's make this connection again. So I'm gonna clear this. Clear this. All right, here we go. All right, so everyone, special products is if I have this, it's going to give me this. And I've proven that if you FOIL this out, you'll get a squared minus ab plus ab minus b squared, and your outer and inner terms produce 0. So you end up with a squared minus b squared. Okay, so this comes from this, everybody. All right, so this comes from this. This is the difference of squares. DOS. That is the difference of squares. It's the difference of a squared minus b squared. It's the difference of squares. Where does it come from? It comes from the product of a sum and a difference. So when I FOIL this out, this term right here gives me x squared minus 16. Where does it come from? It comes from that. Okay? So today we're given this and we're asking to factor this. Well, we know that this came from this. So today, these are my factors. Here, if I was to FOIL this out and I use my special product rule, I will get x squared minus y squared. Okay, that was blast from the past. Now, today, we are given this and we're asked to factor this. Well, this is the difference of x squared and y squared. So that comes from the factors would be this. Why are those the factors? These two binomials multiply to give you this binomial. Remember, we usually get a trinomial, right? But today, that's why it's called a special product, because we multiply two binomials, and this is the first time that we ended up with a binomial instead of a trinomial. So again, if I use a special product rule, this is this times this, which is the product of a sum and a difference. That's what makes this special. You're multiplying the two things that you're adding. Over here, you're adding them, and then you turn around and subtracted them. The product of a sum and a difference. When we do that, we end up with this special product, the a squared, which is 2p. 2p squared is 4p squared. And then the b is 5r. The b squared will give me 25r squared. So today in class, you're given this. And you will soon start to recognize that that's the difference of squares. That's the difference of what squared? 2p and 5r squared. So if that's the difference of squares, then it factors into these two binomials. All right, so I hope that makes a little more sense. This video will be here for you once we get done recording it, once I get done recording it and producing it. All right, so now back to where we left off. So if I look at this term here and this term here, I notice that, oh, I see two binomials being subtracted, right? So that's the key. That's when I ask myself, oh, hold up, is this a difference of squares? Well, 25 is what number squared? 5. G is what variable squared? G. 9 is what variable squared? Well, what number squared? 3. And then K is what variable squared? K. So this is the difference of 5g and 3k being squared. All right. So that's 5g plus 3k and then 5g minus 3k. If I were to FOIL these two binomials out, I would get this, the difference of squares. Again, for the next one, if I ask myself, oh, I see two binomials being subtracted. Is this the difference of squares? That's what I'm asking myself. Is this the difference of squares? Then when you ask yourself that, well, you have to ask yourself, well, what was 121? What was squared to give me 121? That number is 11. What was squared to give me 4b squared? Well, let's look at the number first. 4 is 2 squared. B squared is b being squared. So this is the difference of squares. It's the difference of, and if you want, if it helps to put this up here, it's the difference of 11 being squared minus 2b being squared. That's what I'm gonna do from now on. Okay. If that helps you in the beginning understand this. Well, 11 is my A, right? 11 is my A. 2b is my B. So it ends up looking like this. 11 plus 2b times 11 minus 2b. Now, again, it does not matter which one you write first. I just write this one first because this is what I see first, okay? It does not matter if you write 11 minus 2b times 11 plus 2b. You'll still get the same thing when you factor. All right, I'm going to stop and ask questions. Any questions? Any clarity? Clarity needed. All right, so here I see b squared and 36, but this is an addition sign. Class, is this the difference of squares? Just type Y or yes or N for no. All right, so no, this is not the difference of squares because difference means subtraction. All right, so can we factor? Is there a GCF or anything that we can do with this? Can we take anything out? No. So this is prime. You can't factor it. I can't take out a GCF. It's not the difference of squares. I can't do anything with that. So it's prime. The very next problem, 3a squared minus 20. So I see a difference, but is 3 a perfect square? No. Is 20 a perfect square? No. Both of these have to be the difference of squares. Now, a squared is a perfect square because it's a being squared, but 3 and 20 jack this problem up, and I can't take out a GCF. I can't do anything with that. So my answer, class, is what? Prime. Prime it is. All right. So I'm a little hesitant. So when y'all go watch the video, when you go back, you and the people that are watching the video, you want to pause. And I'm gonna tell you which problems you should do that relate to what I just did, because these next problems are gonna get harder. So the problems I just did that relates to this, because these are your problems for your homework. You're getting a peep at it. It's not many because the foundation is kind of late, and I kind of make these harder. Let's see. Y'all didn't have. Yep. Okay. So the problems that relate to the problems I just did is number 1, number 2. I technically haven't done that one yet because I haven't done 2 variables, and the rest of the problems are like 2 variables. Yep. All right. So all of that for number 1 and 2. Woo! Lord, I hope the success rate on this is going to be great. Okay, so here things get a little difficult, just a little bit. We amp it up. So we have the foundation, and now we're asking ourselves, are these new expressions the difference of squares? So I see 2 monomials being subtracted, and I'm going to ask myself, what was squared to give me x to the 4th power? Go ahead, put them in. What was squared to give me x to the 4th power? Can I square anything to get x to the 4th power? Can I square anything? Can I square anything? Can I square anything? Yes, I can. Thank you. I can square x squared. And then I already know that 121 is 11 being squared. Thank you, y'all. So is this the difference of squares? Yes, it is. What was squared? X squared was squared, and then 11 was squared. So I write this as x squared plus 11 and x squared minus 11. And I'm done. That's my answer, y'all. All right? That's how I do that. 16g to the 4th. I ask myself, ooh, was anything squared to give me that? Well, I know 16 is a perfect square. That's 4. We just learned from the last problem, if I have anything to the 4th power, I can square. It's basically that number squared. Okay? So if I square 4g squared, I will end up with 16g to the 4th. And then if I come over here, 49 is a perfect square, that's 7. And then m squared is a perfect square, that's m. If I square that, I will end up with that. So I have 4g squared is my a, plus 7m times 4g, that's my a, minus 7m. Okay, put a smiley face if that makes sense to you. Sad face if it doesn't. Show them teeth, AJ. I see them teeth. Hopefully y'all brush your teeth this morning so they're pearly whites. All right, Marsha and Mika. All right, so again, 16, look for perfect squares, everybody. 16 is 4. Perfect square is 4, so 4 squared gives me 16. G squared gives me g to the 4th power. Exponent rules. G squared, I'll just write this over here. G squared, remember we distribute, gives me g to the 4th power. All right? So on the next problem, p to the 6 minus r to the 6. Can I square a variable p? Can I square some p to give me p to the 6? If you believe so, put what I can square to give me p to the 6th power. Okay, right. P cubed. I can square p cubed to give me p to the 6th power. And in the same right, I know next year I need space above these to write these problems. In the same right, I can square r cubed to give me r to the 6th power. So is this the difference of squares? Yes, it is. Yes. What is the difference of squares? What are the 2 binomials? P cubed plus r cubed times p cubed minus r cubed. So again, the strategy that we are developing, we're asking ourselves, can we square something to get this term? So 225 is what number squared? 15. And we just learned above that if I have anything raised to the 4th power, if I square that same variable to the 2nd power, I will end up with that. So that's going to be 15x squared. So I can square 15x squared to give me 225x to the fourth. And then can I square anything to give me 9? Yep, that's 3. What could I square to give me y squared? And that's y. So my two factors are 15x squared plus 3y. This time I'll write it as minus because some people will be like, well, I can't write the minus first. I'll just do that on this one just to say it's the same thing. It could be 15 squared minus 3y times 15x squared. Sorry, not 15 squared. 15x squared plus 3y. All right, and the last two for the sake of time and the length of this video, 25b squared is 5b squared, and 9 is 3. But what's the issue with this problem? What is the issue with this problem? Because I do have 5b and 3 to give me 25b squared and 9. Right. This is not the difference of squares. You all are saying that is the sum of squares. This is not called the sum of squares. We cannot factor the sum of squares. So the answer to this one is what, everybody? Good job. Prime, or some people say not factorable, which is a word. Somebody calling me. I don't know who calling me. They're gonna have to call back. All right, and then the last one. I see the difference. Oh, I see the difference. But a squared is a being squared, and 8. I can't square an integer to give me 8. So this is not the difference of squares. There's no GCF to take out. This is prime. All right, y'all. So I am going to, how is this prime? This is prime because it's not the difference of squares. 8 is not a perfect square. This is prime because it's not the difference of squares. 8 is not a perfect square, and I can't do anything with this. So I'm gonna open up the chat. This went longer than I thought, just a little bit. I knew people had trouble with this, but I should expect it. Shouldn't let y'all talk too much at the beginning. All right. So I'm gonna stop the video.